My name is Alfredo Berardelli. I'm professor of neurology at the University of Rome La Sapienza, Rome, Italy, and I'm interviewing Professor Thompson, working in Adelaide. We are here at the 17th International Congress in Sydney, Australia. Good morning, Philip.
Good morning, Alfredo.
So, the first question that I would like to ask you is, tell us about your early years as well as your education.
Well, I grew up in South Australia and attended school in South Australia, then university at the University of Adelaide, and started my medical career at the Royal Adelaide Hospital, where I was an intern and did basic physician training that we have to do in Australia before you subspecialise. I then moved to Perth to do neurology with Professor Frank Mastalia, and from there I was lucky enough to receive a scholarship from the Australian Neurology Association to spend a year at Queen Square at the National Hospital. And I then was fortunate enough again to have the opportunity to join the Department of David Marsden at King's College, where you were working at the time, and spent a very enjoyable and productive time there doing a PhD on motor cortical physiology.
Very well. And why and how did you become interested in neuroscience and in Parkinson's disease and movement disorder? Why this happened?
Well, I remember being fascinated by the muscle spindles during the physiology course at medical school, and I must say I could never understand what we were being taught. And it wasn't until many years later that I became interested in myoclonus and had exposure to patients with myoclonus, and all of a sudden I realized that the muscle spindles did indeed have a very important function and were relevant to the central nervous system as well as to peripheral neuromuscular control. I found the exposure to Professor Frank Mastalia very rewarding and very stimulating, and that pushed me into neuroscience, or the scientific aspects of clinical neurology, I guess. And
so, together with Frank Mastalia, you worked on neurophysiology mainly, or?
Well, that was part of my general training at that time, but he had a particular interest in many areas of neurology, but was interested in neurophysiology, and I guess he kindled my interest in the motor neurophysiology that I found interesting, and it brought back this fascination that I'd had in my earlier medical student days. And of course from there the door opened to work in motor physiology at King's College with David Marsden and colleagues such as yourself.
And did you manage an understanding how spindle work?
No, I still don't understand, but
Okay.
it doesn't trouble me so much now.
Okay, who were your role models and heroes in the field of movement disorder and the field of neurology in general?
Well, in neurology in general, I would have to say Frank Mastalia was my early mentor, and then of course David Marsden was tremendously influential, as he was for so many of us. It was also fascinating to look around the world and see people like Stan Farn and Mark Hallett, who had made significant contributions in movement disorders, and it was a field that was alive, and I think still is.
So you moved from Queen Square to King's College at the beginning of your period in London.
I did a general year as a registrar on the house at the National Hospital at Queen Square, and then went to work with David at Denmark Hill in the department of, well, in what was the department called? It was
Department of Neurology.
It was a department of neurology,
yes.
But we worked particularly in motor physiology.
And then you started immediately working in neurophysiology. Do you remember the first experiment that you did and first project that you did in that period?
Well, I can remember there were a number, and we all used to experiment on ourselves, as you know. And usually the new person on the block was the was the person who was the subject for the experiment. And so I can remember spending several months being the subject of a whole range of experiments, from performing movements to having my brain stimulated. At that time, magnetic brain stimulation hadn't been invented, and we used to stimulate ourselves with electrical brain stimulation, which you remember, and we would perform things like post-stimulus time histograms, sitting in a chair for hours, contracting a motor unit and stimulating our brains. And I remember being called by, I remember we got a call from Pat Merton, who I should say is another very influential person, who said that he had received a call from Tony Barker in Sheffield, and who had brought down this new machine to stimulate, that could stimulate nerves, and he wanted to know how it was best applied. And this was a Heath Robinson concoction of a series of coils that Roger had put on his arm and would stimulate the peripheral nerves. And Pat Merton, in a moment of brilliance, put it on his head, and lo and behold, it stimulated the brain, and that was the beginning of magnetic brain stimulation. So that was a very interesting development, I recall.
But in that period also electrical stimulation of the brain really was a great technique in understanding a number of important function effect of motor system, motor control. Don't you think?
Yes, yes. Well, we looked at all sorts of things at that time, and I think we were among the first to show that there was slowing of conduction in demyelinated central nervous system pathways in the corticospinal tract, obviously, in patients with multiple sclerosis.
What do you feel is your most significant contribution to the field?
Well, I'm not sure if I've made any significant contributions.
I'm sure you did. Probably the difficulty in selecting the best one.
Well, it was a very great privilege and pleasure to be part of a team that worked out the mechanisms of action of electrical and magnetic brain stimulation. I think that was a team effort, and it was really very exciting at the time that we had this new technique, and we could do a number of experiments on ourselves, and find out how it worked, and with that information put it to use. And of course that field has exploded since then and opened all sorts of new methods of investigation of the human central nervous system and human movement.
What have been some of the great scientific challenges in your career?
Well, I think everything that we do is a challenge. I think every time you start on a new project, it's a challenge, and you often don't really know where it's going or what's around the corner. I think there are many challenges that remain. I think that the understanding of the breakdown of the normal physiology in diseases of the motor system, such as Parkinson's disease, still represents a significant challenge, and one that I'm sure will keep us entertained for many years to come.
No doubt that understanding motor physiology and knowledge of motor physiology, but in that period of your life was everything was almost unknown, so everything was something new.
Yes.
Because, I mean, nothing was known before. In that period was really an explosion of new things.
Yes. Well, I think that's right, and it was a great privilege to be part of all of that, and I think we identified. We didn't discover new things, but we identified what a lot of different movement disorders were, and that was another very interesting and satisfying thing to have done. All of the unusual movement disorders and working out where they were classified, and with the help of neurophysiology. I think that one of the big things that I learnt was that if you look when you start to do an experiment on a movement disorder, very often you realise that it is much more revealing if you spend a lot of time looking at what the clinical problem is, and that the more you look, the more you see. And so a lot of the experiments, as you know, take a long time, and so you are there with the patient for often hours at a time, and at the end of that time you have a much greater understanding of what the problem is from a clinical basis, and of course that enables you to become more focused and more innovative with your neurophysiological investigations, and I guess that's a really important thing that I learnt and found very enjoyable.
But not only this, really I think that all a number of pathophysiological mechanisms underlying the various movement disorders in that period have been really clarified, understood, don't you think?
Yes, 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 yes.
Where do you think the field of movement disorders is headed in the years to come? Now that in that period certainly pathophysiology, motor physiology, clinical classification were the most important aspect. What do you think?
Well, I guess there are a number of ways to answer that, and one is to look at how techniques drive periods of investigation and advances in knowledge. As you've just said, the use of neurophysiological techniques created an explosion of knowledge, and for a period of time physiology was the most important thing. In parallel with this, that was neuropharmacology, and there have been lots of developments, and there continue to be lots of developments, but imaging became very important, and then different modalities of imaging. So I guess you have to look and see whether there's a new clinical technique that or investigative technique that will drive a new period of research. Genetics, I guess, is something that is a hot topic at present. I wonder whether a combination of physiology and the new sophisticated imaging will lead another forefront of investigation in the years to come. Of course, the imaging techniques are very expensive, so that limits where they're available. But I wonder whether a combination of physiology and anatomy from imaging will be the lead a new wave of investigation.
I perfectly agree with your point. One important thing is with motor physiology and motor mechanism, what you really need is to always have some good ideas, and then to apply and look for that idea in different conditions, different clinical, in different diseases. Don't you think that?
I think you make a very good point.
A good idea is the most important thing.
I think you make a very good point, and I think very often the good ideas come from careful observation of clinical phenomena. So we come right back to where we started, that the clinical phenomenology is very important, and it's the patient and their diseases that are very important, and that's where the ideas will probably come from. And very often, as you know, when you set out on an experiment looking at a clinical problem, you find that you're not getting anywhere, but along that way you find you develop an idea that's quite unexpected, that might take you in another direction, but is very productive. So you never really know what's around the corner, but the important thing, I think, is to keep trying to apply new techniques to problems that you don't understand, and keep looking at patients and seeing if you can find out new areas of their problems that you can explore.
Do you think that having all this background research, and particularly in pathophysiological mechanism. When you see a patient, you look at him in a different way.
Yes.
Or not?
Yes, no, I think without doubt. Without doubt, I think that you understand the patient's problems, their clinical problems, to a much greater degree, greater depth, having considered the pathophysiology and having explored the physiology of the problem. I think that without doubt that's a very important thing. And I try to teach my medical students and residents to think in that way, to think along the lines of what is the physiological basis for this problem and how does it affect the nervous system, and that the clinical problems that occur arise from a perturbation of the basic physiology, and what is that perturbation, what is happening. And so I think you do look at things in a different way and in much greater depth.
So you always think to systems and to mechanisms when you see a patient with a particular signs, with a particular symptom.
I think I always try to think in terms of trying to understand how this is happening, why this is happening. I'm not always successful.
Well, but no doubt that this is a very useful approach, different from the approach that is probably now most often used, but it's certainly the best approach, I guess.
I think you understand things better if you try and think about how things occur from a mechanistic point of view.
So, what advice can you give a young doctor and scientists entering into the field of neuroscience, and in particular into the field of Parkinson's disease and movement disorder in general?
Well, I think for clinicians, for clinical neurologists who are entering a period of or want to subspecialize in movement disorders, I think it's very important to spend a good period of time in the clinic, working with patients and understanding how patients come to you, how they present, and what the problems are that they present with. And then I think it's very important to try to have a period of research where you have the time to sit and think about the problems from a mechanistic point of view, just as we were discussing. I think that is very important. And in order to do that, I think it's important for people to travel. I think people should go away. I think that they should work in other departments. They should mix with their fellows from other parts of the world and expose themselves to other ways of thinking. I think that's very important, and that was very important to me too, I think.
But do you think that this type of approach is still possible nowadays, that things are changing and we don't have much time for doing this sort of thing?
Yes.
So we are obliged to see a number of patients and financial resources are limited. So you think that...
and the regulations for moving from one country to another to practice for a period of time are also changing. And I think I think it's a pity that those things are happening, and I think we'll be the poorer for it. But I still would urge people to see how others practice, to see how others think about things, and to find a place to go to where you can do a period of research, where you have time to reflect on the problems that you'll encounter later in your clinical or academic career.
If you could wind the clock back 20 years, would you do anything differently, or would you do exactly the same thing?
I think I would do exactly the same thing.
Good. This is very good.
I've been very fortunate, and I've enjoyed the whole journey, and I still very much enjoy clinical neurology, and I very much enjoy movement disorders. So I wouldn't do anything differently.
Tell me what is your feeling when you write a paper, and you finish the paper and the paper is then accepted?
I think there is a great sense of achievement whenever you finish a paper and it's accepted. And it's very nice if you're quoted, and it's very nice to feel that you've made a small contribution to the literature on the topic. I think the other thing is also, perhaps on a personal level, is that when you write and complete a paper and put it all together, you actually learn quite a lot yourself. It's surprising how much, with editorial rigour and putting all the facts in place, you realise that you've actually learned quite a lot in the process.
You also made a number of collaborative papers with colleagues all over the world.
Yes,
do you
yes,
think it's a good thing?
Yourself included. Yes, I do. I think it's very satisfying to produce something in collaboration with other people, and I think it builds the bonds of friendship, and I think we all like the idea that we can work with people and do something that's interesting, constructive, and hopefully useful.
Changing subject, what do you do to achieve a good work-life balance? First of all, did you achieve?
Well, I'm not sure. I think we all work hard, but I think we have to do that. And I think if you're a clinician and an academic, you have lots of balls that you have to keep in the air, and this is quite difficult. And it means that you do work very hard, and if you're going to do things like write papers or do experiments, as you say, you have to compartmentalize your time very carefully so that you can actually do these things. But to relax, one of the things that I have taken to doing more recently, which I've enjoyed for a long time, but there was a period where I couldn't do it, was play golf.
Okay.
And that I find is very relaxing. There was a period where I didn't play for nearly 10 years, but since returning to Australia, I've begun to play. The other thing I like doing is I've also had a long-standing interest in bird watching, and I have again not been able to do that for long periods of time, but have recently taken an interest in that as well. Not in a very serious way, but just in a way that amuses me.
Well, very good. What kind of role has the Movement Disorder Society played in our field?
Well, I think the Movement Disorder Society is playing a tremendous role in educating people about movement disorders. We've talked about the growth in understanding of movement disorders, and this is now being made available to a large number of people, both through our annual Congress, which I think have been extremely successful and extremely well planned, with a great diversity of topics covered from year to year, but also from education programs that are now being carried out throughout the rest of the world, throughout the rest of the year. So
also small meetings.
Small meetings and a range of educational activities, so that we have an exposure at the annual Congress to 2,500 to 5,000 people, and throughout the year there's exposure to another 3,000 to 4,000 people. So I think this is a significant achievement from the society.
Do you remember any specific small meeting that you enjoyed from a scientific point of view, and also from?
Well, I think we've had many very enjoyable small meetings. I think one of the ones that stands in my mind was the meeting at Spoleto, which was a very enjoyable meeting that you organised, with some very vibrant social activities, as I recall.
Indeed. Did you experience bias or career or barriers during your career development, or
No, I don't believe that I have.
you
No.
never had?
No, I don't believe that I have.
Some people sometimes experience bias or barriers.
Yes. No, I don't believe I have. I think that the biggest barrier to continuing the activities that we do today, I think, is the difficulty in obtaining research funding. I think this is a significant barrier, particularly if you have a busy department and have busy clinical activities. To continue to obtain funding to support research, I think, is a very difficult activity, particularly in our climate in Australia.
So you didn't experience any barrier, but do you think that nowadays young colleagues or young doctors face some barriers or different types of barriers?
I think that there may be a change occurring in young medical graduates. I think that many are entering technical-based specialties rather than specialties like neurology and movement disorders that have a strong clinical emphasis. And I think also the pressures on people to work seeing patients are interfering with the capacity to have a period of time in research or a period of reflection over the specialty. So I think that this is a if that can be called a bias or a barrier, I think that's a risk for our specialty for the next generation.
Last question. Are you happy in general with your life, with your work?
Yes. I mean, I'm very happy. You asked about the work-life balance. I'm very happy. I have a very lovely family. My children have now almost grown up. They're both at university, and we enjoy each other's company. And I've been very supported by my wife Liz, who also has a career and is working. She's perhaps working harder now than she was before. So yes, I think I've been very fortunate in my life. I'm very happy, and yes, I think.
So, I'm glad hearing this thing, and thank you very much for this interview.
Thank you, Alfredo.